Welcome to Lab 4 on spring mass oscillation and the energy principle. For this lab, we were given footage of an oscillating spring, which we were to observe using Tracker, and then attempt to model accurately using Glowscript according to fundamental principles, and then compare and analyze our results. So our first set of fundamental principles and assumptions are Newton's second law, obviously. I'm not going to repeat that one. Hooke's law, and then we're assuming that gravity on Earth is equal to 9.81, and our final assumption is that our only relevant forces are F-grav and F-spring. Now, further principles are, we're assuming that our system is the mass, spring, and the Earth, or we're setting it as that, and therefore our total energy is gravity potential, spring potential, and kinetic energy, which I have given the formula for below. More on that later. Now the first step was to initialize all of my things in Tracker, so my yardstick, my frames per second, my mass, my start frame, mark my center of mass and my axis. You can see how I've done this on these screenshots here. Now after that, I had to export this data to Excel, which I had to format a bit into a CSV, so that I could then form a graph from it in my Glowscript. Now to set up my Glowscript model, the first thing I had to do was again make a bunch of initializations. You see these here. Some of these are given to us in the video or in the assignment, for instance the mass of the ball, our yardstick. And some of these I had to work out, such as my spring constant, and some of these are obviously calculated. Now, the second and more interesting part of this Glowscript code is our equations that we're enacting every time we run the loop. However, I've already stated these equations at the start of the video. These are the equations for the force of gravity, the equations for the force of the spring, Newton's second law, and then of course our energy calculations. And it should come as no surprise that delta K is K minus K initial. Now, this is the result when my Glowscript code was run and compared with my Tracker model. You can see there's some imperfections here, which I have tried to work out by adjusting the spring constant. However, the degree of precision achievable is limited, but I think it's a very good approximation. What does it mean? So, does the result of this satisfy the energy principle? The short answer, in my opinion, is yes, because delta E is remaining relatively constant. Now, there are some fluctuations which are due to errors in my model, but overall, you know, it's sticking near around zero, and the fluctuations are accountable for due to error. And essentially, I see no reason why this does not satisfy the energy principle if delta E in the system remains relatively constant at zero. Because obviously energy can be converted even if it can't be created or destroyed. Part 2, a much more interesting question, is the two different estimations of oscillation periods. So I obtained from Tracker the X and the Y period, and both were around roughly 1.5 seconds. But I think what was interesting is that the Y oscillation was less consistent. They were both roughly the same figure. However, the Y oscillation was variable, and I wasn't initially sure why this was. But after further consideration and looking at my model as well, I started to realize that there's some inconsistency around the transferal of kinetic energy, in that you know, the kinetic energy is sometimes going to the X direction, and it's not, the energy transferal is not always consistent. This is at least my understanding. Some final notes to consider, I'd appreciate it if you read these before grading harshly, are my ODS accommodations and background noise. Thank you for listening, and I hope you understood my code and my Tracker model and the fundamental principles. Thank you very much.